Hello everyone, welcome to the video lecture series number 2 on the topic linear and digital integrated circuit. In the last class, we discussed about the different types of the gate that we saw about NOT gate as well as AND gate. So here, let us see about the OR gate. So generally, the OR gate is true when any input is true. That is, if any single input is true or both the input is true, we'll get a true output. The plus symbol is used to represent OR in the Boolean expression. So here you can see that this is the symbol of the OR gate and it consists of two inputs, that is X and Y, and the output is Z is equal to X plus Y. And the corresponding truth table is shown here. That is, for the inputs X and Y, you have an output Z. So in this case, if the input is 0 and 0, the output is 0. And in the next combination, if the input is 0 and 1, the output is 1. For the next combination, if the input is 1 and 0, the output is going to be 1. And again, if the input is 1 and 1, the output is going to be 1. In each combination, you can see that if any of the one input is high, then the output is also going to be high. If any of the one input is low, that doesn't matter. Again, the output is going to be high. And if both the inputs are low, then definitely the output is going to be low. That is the characteristics of the OR gate. Now moving to the NAND gate. So you can see the symbol here, symbol of the NAND gate. Again, this is a 2 input and a single output. Here, the input is represented as A and B and the output is represented as Q. To create a NAND gate, and AND gate is combined with NOT gate. So we can say that a NAND gate is nothing but the combination of AND gate and NOT gate. You can see the truth table here. In the truth table, there is 2 input 0, 0, 0, 1, 1, 0 and 1, 1. For the input A and B, if it is 0, 0, the output is going to be 1. And if the input is going to be 0, 1, the output is again going to be 1. And if the input is going to be 1, 0, the output is same, which is nothing but 1. And if the input is 1 and 1, the output is going to be 0. So you can see here for the AND gate, the output was 0, 0, 0 and 1. And for the NAND gate, which is exactly the reverse of it, the output is nothing but 1, 1, 1 and 0. So now moving to the next gate, which is nothing but the NOR gate, is exactly the opposite of the OR gate. In the other words, we can also say that the NOR gate is the combination of OR gate and NOT gate. You can see the symbol here, which has 2 input and an output. And the bubble here represents the inverse of the NOR gate. And the output C is nothing but AB, the whole bar. Now you can look into the truth table also. In the truth table, you have the input as well as the output. Here the input AB is again the combination of 2 digits, that is zeros and 1. So we are going to have 4 combinations of input, that is 0, 0, 0, 1, 1, 0 and 1, 1. So you can see that there are 4 output, which is in the manner 1, 0, 0 and 0, which was actually the inverse of the OR gate, which was 0, 0, 0 and 1. So this is exactly the opposite of OR gate. Now moving to the XOR gate. So XOR or exclusive OR is defined as being true when one input or the other is true, but when both the inputs are true, when both the inputs are the same, then the output is going to be 0. So here the symbol is represented in this manner and it is used to represent XOR in the Boolean expression. Input A and input B is given to the XOR gate and the output here is shown. That when the input is 0, 0, the output is 0. And when the input is 0, 1, the output is 1. And when the input is 1, 0, the output is 1, and the input is 1, 1, the output is 0. So this is nothing but the XOR gate. Again, when both the inputs are same, the output is going to be 0. Now coming to the XNOR gate. So in the XNOR gate, as we saw here, is exactly the inverse of XOR gate. So in the exclusive NOR gate, we can see that this is exactly same of the symbol of the NOR gate, and the output consists of bubble and two inputs and output, and we can see here the output is exactly the inverse. Thank you. The remaining we'll continue in the next class.